Okay, guys, it's about 1 o'clock. Let's get started. Thank you for coming back today. This is the second day of the 5-day webinar that we're giving for the Coastal Modeling System basic course. Today we're going to be covering, I'm showing the agenda that's on our website now. We're going to be covering a little bit more with working with bathymetry. I'm going to go back over a little bit of the horizontal reprojections that we did yesterday, and then we're going to start covering doing some vertical datum corrections to get all the vertical information into the same format. And then we're going to go over working on CMS flow, creating grids with the variable spacing and how to set up parameters, boundary conditions, various things like that. And then if there's any time left, we'll cover some questions, and depending on how much more time we have, we may start a little bit extra today. But to start off with, I put some more files up on the website. So if you do go to the website, and again, I'll show you where that's located. If you just go to cirp.usace.army.mil, and under Tech Transfer, there's Webinars, and go to the Coastal Modeling System Basics. And I've got the agenda if you scroll down to the bottom of that. So these links for working with bathymetry continued, that gives you a kind of a hands-on version of the files we're working with today. I'm not going to do it as a hands-on, but it will be a little bit easier for you guys to follow along on your own, either while I'm talking or offline. And then there's also a link here for CMS Flow in showing how to use the files to create our grids. Sample data today is going to be the CMS Humboldt directory, and it's got a few files. So if you go ahead and download that, unzip it, then you'll have the files that I'll be working with. Any questions before I get started? Like I said, I'll go back over a few things that I covered at the end of yesterday. Otherwise, I'll go ahead and get started. So where we left off yesterday, we were working with the bathymetry folder, and it's got 6 survey files. And what we had gone through is pulling them in and trying to get all of our horizontal coordinate system information so that all of the surveys are overlaid onto the projection that we want to use for our CMS Flow project. I figured maybe right next door. I'm just curious how much it's all. Yeah, I'll order. I'm hearing some feedback here. I'm not sure who's talking. Okay, I'm sorry about that. Okay, so let's just get started again. So what we're going to do is go into CMS and SMS. I'll start it from scratch so you guys can see how to do that. So you basically go to your start menu and you start SMS 11. Hopefully it won't take too terribly long. Sometimes, depending on the speed of your computer, it may take a minute or two to get everything set up. All right. Once that's loaded and you see the screen, what we want to do is start pulling in information. And sometimes you will already have files that you've already saved. But in this case, we haven't saved anything. We're just going to work straight from the files that are in this bathymetry directory. So what I'm going to do is go through and I'll select all 6 of these files and I'll bring them in at one time. So if I click and drag and drop them into the graphical section of the SMS interface, it'll start processing those files one at a time. And as we showed yesterday, there's a couple of steps here. The first is just to decide where the delineation for the different columns are. And so you would set that here. I'm not going to go into detail. This is pretty basic. But for the purposes of these files that I've provided, The X and the Y and the Z are always in the same order, so we're just going to select these and go through. I'll click Next on this first one. If you needed to change the order from eastings and northings in these two columns, you would just pull these drop-down menus and change whether it's the X and Y or whatever you want. You can have multiple columns here, and whichever 3 columns you need for the X, Y, and Z, go ahead and set that. And for the other columns, if you don't need them, there's an option for Do Not Map This. So let's go ahead and accept this. I'll click Finish. And I'll do the same thing for all 6 of these files that I've loaded. And you'll see when I get to the one that is working in geographical coordinates, which is this one, because of the precision that was provided to me in the file, a lot of these points will be considered duplicates. So it'll tell me once I click Finish that I've got about 48,000 duplicates, 43,000 duplicates, and they're removed from consideration. So it moves on to the next one. So I'll keep processing. Hopefully I'm not going too fast for you guys. As I said, this is a little bit of a refresher from yesterday afternoon, and then we'll get on to some new material in just a few minutes. All right, now that all 6 have been processed, it's triangulating them, and we'll see that in just a few minutes. Can everybody see my screen okay? Let me just share it directly. That may be a little bit better there. Okay, so we've got the 6 data sets loaded in our tree, and we need to work, first of all, the first choice is to decide for your project what projection you're going to be in. We're working with the Shark River Inlet area in New Jersey, so we've decided to set our projection, which is under Edit, Projection. You choose the global projection and set it to be State Plane, New Jersey in meters. Click OK, and we make sure our vertical is in meters as well, and click OK. And you notice we have to do this pretty much every time we come into SMS. If you are working in an area and pretty much all of your projects are going to be in the same area, and you always want to use State Plane or UTM or whatever coordinate system, one thing that you can do is to go ahead and set that projection one time, like I just showed you, and then under File, there's an option to save your settings. And then the next time that you come into SMS, after you do that, it'll always be in that projection. But you just want to make sure that when you're starting a grid, working with a project from scratch, just to make sure that you are in the right projection. Never make an assumption that you have set everything up ahead of time like that. So let's go ahead and start getting all of these different surveys. You see we have 3 different areas here that we need to get all overlapping. And so the first one is this LiDAR feet NAVD survey that's here. It's shown in red. So anytime you select the data set in the data tree on the left, it shows up in red on the right. So we will right-click that option, tell it to reproject. Select what projection that the survey came in, and so we've got, this one was in State Plane Coordinate System, New Jersey, but in feet, U.S. survey feet. And even though the vertical, the depth information may be in feet or meters, I'm not going to make any change right now for this. I'm going to do all that later in the data calculator. But to make sure that there's no change, unintentional, you need to make sure that what you're converting from and converting to is exactly the same. That way we can do the operations later on. So let's just switch this to meters for right now and click OK. And so when it's finished processing, you'll see that this line of LiDAR survey has now been moved to a different location. And so that's shown there. We'll move to a different, I'll just cycle through some of these different surveys that we have loaded. I know that the 0.75 meter contour is already in State Plane, New Jersey meters, so I will not be converting that. If you look in the file that I provided today, I'll show you what that looks like here in a second. So this document that I'm providing today has a lot of textual information that you can step through the steps that I'm going through. But there are a couple of tables that I've listed in here, and one of them is on page 6. And so this basically says for the file names that we've loaded and we've tried to convert here, what their horizontal projection information. We may have gotten these from metadata files. We could have gotten these from just information from the person that did the survey. But I've made a little table of what the files as they came in, what their projection was, so that I know how to do the conversion later on. We see that they're all in 8083. We don't have to worry about that. So this particular one, 0.75 meter contour, State Plane, New Jersey meters, we do not need to reproject that. Same thing for the field team measurements, but the other 4 we do need to convert. So I'll go back to my SMS now, and I'll click on the 3364 channel survey here. We see it's up in the upper right. I'll right-click, tell it to reproject, and again I'll go through and set the projection to be New Jersey, State Plane, U.S. survey feet, and vertical in meters. It's been moved. It's down here. It's hard to see, but it has changed locations. So I'll select the next one now, and that's this channel survey here. So I'll do the same thing. Right-click, reproject, global projection, State Plane, U.S. survey feet, New Jersey. And as we go through these, you'll see the screen updates, and the only one left is this one down here, which is the coastal relief model. I'll reproject that. And this particular one, as we see in the document, coastal relief model, it's in geographic arc degrees. So I can come back to the SMS, and I know which projection to set it for the conversion to State Plane. Once you've finished working with all of your data, you should pretty much see everything in one screen. If you do a frame and you still have some data that's showing in a different area, you want to make sure you find that and figure out why either the reprojection that you did not work, or to go ahead and reproject that information. So now that we have those all converted, I'm going to show you how to, one of the most important things that you need to consider when you're starting a project from scratch, and that's the Save button. So basically, whenever you do some steps and you don't want to mess that up, you want to have something to come back to later on and not have to go through all these steps again like we've done, I would go under File and just tell it to save. And what the easiest way to do it when you're starting from scratch is just to save a new project. It has a .sms extension on it, and what you'll do is you'll just give it a name. So I'm going to name this webinar, and you don't have to worry about anything else. That's going to be a prefix that's added on to these files that are all showing in the data tree. So whatever is showing over here will be saved with this one step. So we click Save. It'll take a couple of seconds depending on how many files you have loaded. All right, it'll come back, and if I look in my folder now, my bathymetry folder, I now see some extra files. These are the ones I started out with, but when I just saved, I wound up with these files here. So it tacked on a prefix called webinar and kept the same name that it used before. You notice that a few of the files now are H5 files. That's just a binary representation of this ASCII file so that they load faster, and you can keep all kind of connection type information for that tin. So the next time we come into SMS, I'll go ahead and close this out and restart it. Rather than loading each one of those individual files like we did and having to go back to the reprojection, we can just click this webinar.sms and bring that one file into the window, and we'll end up with everything loaded as we did. It's showing all in the right space, and our projection is still what we initially set it to, so it remembers all of that information. Are there any questions on what I've covered so far? No. Okay. So now that we've saved that, I've noticed that the version that I'm using of SMS 11, it looks like a couple of things have changed since an earlier version of SMS 11. Used to, there was a double underscore here between the prefix and these file names, and now they're putting a dash instead. That should still be fine. Everything should load without a problem. So it's just something that if you're used to working in SMS and things operating a certain way, that's something a little bit different with this latest revision that they put. One of the things that you might want to do is to look at these, instead of being points in this big gray blob here, you might actually want to look at the contours themselves. So what you can do is under Display, there's Display Options, and there's a couple of ways to get to this dialog. So there's Display Options here. You can also click this little monitor that's showing in this tool right here, but that brings up a Display Options window that has a few things loaded, and it just depends on what all is loaded in your data tree as to what options are showing in this dialog. But basically right now the default is to show scatter points with just the points and no contours and none of this other information showing. So if you wanted to look at contours instead of points, you could unclick the points and select contours. So that will turn on the contours. Then you can click the Contours tab and show how the actual contours will be displayed on the screen. So there's different methods. There's a linear method, which is just lines and no other information. I'll show you what that looks like now. And then there is a range down here that it defaults to whatever the normal range is for the survey or the data set that is selected. So this data set has a range from 1 to -16. If I click OK, we should be able to see that. So everything else disappears. You can only show contours for one data set at a time, so each one of these has its own. As you see, they're changing around here. And you can zoom in with the zoom tool and look a little bit closer. So you see a lot of information, and these are just lines. So if you wanted to see filled contours instead, you can change this from linear to color fill. You can change this range if you only want to see between, say, 1 and 15, negative 15. You can do that. And notice that your legend up here reflects those changes, and then your display changes here. There are a couple of questions, and I think that Alex is handling those right now. But I'm going to move on. So each one of these, I'll go ahead and frame again. And as I said, framing is this big magnifying glass right here on the top. And whatever is selected is supposed to be showing up. It puts that to the extent of the entire frame here. So each one of these may be larger or smaller depending. So I'll zoom back out. You can kind of see what's going on here. We have some positive values here that are showing up in blue. We have negative values here that are showing up in red. And this is different than we normally work in. I told you yesterday that CMS works with depths being positive. That means that in the ocean, the deeper you go, the more positive the value. And this particular data set and several of them over here are all opposite of that. They're in an elevation type format instead of a depth. So one of the next steps that we have to do is to switch those around. So I'll go through and I'll look at each one of these. Some of these we have to convert and some of these we don't. Let me look in the file here and see what it says here. So we're in the next section now, 1.3, working with vertical datums. So as specified, the vertical datums, the depths have to be positive. And the easiest way to do that is to use a tool that switches depths to elevations and back and forth in one step. So what we can do is to click the first data set. I'll just start at the top, the 0.75 meter contour. Under Data, there is a Transform option. You click Transform, and there's several options here. You can try some of these, but you have to really know what you're doing because those are actually moving the data either by zooming in and out, scaling them, or translating them to the left, to the right, or an actual deeper value. You can rotate based on the point of origin, things like that. Normally, the only thing that I use this particular dialog for is to just switch the sign, depths to elevations. And so you can tell it to frame after each transformation, which is fine for me. I'll just do that. So with the button selected, depths to elevations, I'll click OK. And for that particular data set that I have selected, not every one of them, just the one I've selected, I now look, and if you look at the bottom of the screen, it shows what the value is, negative 0.75, and that's fine for me. So I'll do that for each one of these other data sets. So now on the second one, we'll go to Data, Transform, Depths to Elevations, OK. And now we're changed. These are actual depths instead of elevations now. We'll keep working. Data, Transform, Depths to Elevations, OK. And I'll just do the same process for each one of these 6 data sets. Now there's another way you can do this if you want. Some people use this method. You can also go into the data calculator, which I'll show in just a minute, and actually do an expression to multiply this value by a negative number. But I figured that is, we can use that for the more complicated things. This is a one-step solution to changing these values, and I like it much better to do it this way. So under data, we'll go to transform. We have one more to do after this. All right. And so you notice that originally the value for this range depended on the range of the data set that was selected. And I had changed that to 1 to -15. Well, that kind of locked it in place. So if you go into the display options again and look at those contours, you see that this box is selected to change the to specify a range. If you deselect that, then each one of these will distribute the colors based on what that particular data set does. That's not necessarily helpful. So what I normally do, my preferred range is in the display options, is I normally look at from -5 above water to about 20 below water. And then we can specify a precision. I normally use 2. And then that way, everything that you see is always kind of looking the same way. Your land areas are always, I'm zooming in here, your land areas are always reddish to yellowish, and then the near shore is green, a little bit deeper water is blue. And once you get the full grid built, then you'll be able to see this a little bit easier. So we see the deeper waters, the higher elevations, and then the bays are the yellowish to green. Are there any questions that haven't been answered so far? The question that's been asked is when you transform the scatter sets from depth to elevation, whether or not that information is reflected back to the file. The answer to that is no. If you loaded a file and you made this data transform depths to elevations, all that's doing is changing the value of the information that was read in. It does not automatically save that back to your file. That way, if you choose not to save over your files, you don't change anything. So what I normally do is, once I have everything like I want, I'll go back and I'll save again my project. If you've already named it, you don't have to go through and name it again. And so we have our original files that we started out with, and they are exactly how we got them from, say, the surveyor or whoever else. But the files that are associated with this project are now the changed and updated values. I hope that answers the question. Okay, so I'm going to frame here. I will try to follow along like is written in the hands-on document, just so that I don't do anything out of order from what you guys might want to cover later on. So we're at a section called Local and Regional Datums, and basically there are a couple of different types of datums. And as it says, some are local and some are regional. So depending on the benchmark, depending on the area, the values of what is mean high water will vary from place to place. So the values that you get there are all local datums. Things like NAVD 88, NGVD 29, those are regional datums. And so those are values that are not as tied to the location. They're on a regional level. So as I showed yesterday, there's a website that I go to get these benchmark sheets, and they're very convenient. I'll go there again. I'll just pull up the web browser, and the address is tides and currents.org. www.noaa.gov. And I believe that's listed in this handout. But when you come here, there is a lot of information on this site, but one of the things on the left-hand side are benchmarks. So there's the present epoch, which is what we always want to use. And then if you're modeling a time in the past and you want to use the superseded epoch, you can do that. You can get that information too. Normally we're doing projects that are in near real time, present epoch, and then you can just find what area you're in. We are in New Jersey, so there's a list of states here. I'll click New Jersey, and on the main part of the page now it shows every benchmark that NOAA has for the state of New Jersey. And so we're using Long Branch, which is 8531991. So you can click this and get the benchmark sheet that is shown in the document. And there's other information as well. It shows where the benchmark is located, some description information. But towards the bottom of these benchmark sheets is this relationship between mean lower low water, mean high water, and some of these also have NAVD88 included in those as well, like this shows 0.819. So this is all information that you're going to use to be converting from your different surveys to the preferred datum that you're going to be using for your project. And for this project, we've chosen to work in mean sea level. That's this particular one, 0.744. And that 0.744 means that it's 0.744 meters above mean lower low water. So that just gives us a point of reference. As I also said, it's nice to just build a little chart here of how these relationships are, mean lower low water and above that, just so you can get a grasp on how these things are related. So for each of these files that I brought in, I've made a second table that's on page 10 that shows what the vertical datums are. And so for the channel survey, we've got mean low water in feet, and then another one is mean sea level in meters. It says it's not accurate for near shore. We're not going to worry about that because we're all using it for deep water. So each one of these has a certain datum, and based on the benchmark sheet here and your diagram here, we can decide on what the actual conversion from one to another will be. And so that's what this information that I've put in the chart is showing. This is an area you need to pay close attention to because this is where many people make mistakes with these datums. And if you start out with the wrong information, how you add these surveys together, you're going to wind up with not good answers in the end. So just take a little extra care when you're putting these surveys together. So what we want to do now is start converting. I'll go back to my SMS. Start converting each one of these data sets into the datum that we want to use, which is mean sea level in meters. So I'm going to move this over real quick so I can work. And so I'm going to keep an eye on this chart here. All right, and I'm just going to move through each one of these options and show how we convert the datums using the data calculator. So the data calculator is under Data, Data Calculator. If you choose the Dataset Toolbox, it's also located within there. It's just one of the options in this Dataset Toolbox that has many other options on the side. So if you choose Data Calculator, you'll see that each one of these data sets has three components. There's an X location, a Y location, and a Z, even though it only shows the Z normally in that data set. But when you're trying to work with different expressions here, they give you the option to be able to use the X and the Y values as well. So what we want to do is use the representative code for the corresponding data set that we want to use. So for this particular one, 0.75 meter contour, the Z is actually given D1. So we can either type in D1 into the calculator spot, or we can double click it, it'll show up over there, or you can just click it here and then add to the expression. There's always 2 or 3 different ways normally to do things in SMS, and you just find the one that makes the most sense and easiest for you and keep with that. So for me, I normally just double click the value, it shows up in the calculator, and then I can put some simple equation in for that. So we've already converted these from elevations to depth, so we don't have to change the orientation from positive to negative, so we don't have to worry about that. So just put in the Z value, and for this one I'll find it in the sheet here, 0.75 meter contour. This is already in mean sea level. We don't even need to do anything for this. So I'm just going to click done and go to the next one, which is 3364. We see that's in mean low water in feet. And so I'll select that, go back into the data calculator. I'll double click D1, puts it into the calculator. And first I convert from feet to meters, and then I convert from one datum to another. And it just depends on what you want to do. So you can do this in any order. Actually, I think what's shown in the book is to convert the datum first and then from feet to meters, so I'll do that. So for this particular one, it shows in the book that the conversion from mean low water to mean sea level is to add 2.76 feet. So I'll do that. I'll add 2.76. I can give it a name, and I'll say that this is now mean sea level in feet. Make sure you click the compute button, and you see we have a new option that shows up in the data set. You can now double click that one and then convert that from feet to meters, and for me I multiply the data by 0.3048. I'll give it a new name, mean sea level in meters. I'll compute. Of course you can combine those steps, but I find it's easier for me to do one thing at a time, and that way I know that I have not made any kind of mistake. So now that you're finished, you see mean sea level meters there. You can click done, and it shows up over here in your data tree, and you can actually zoom in and click each one of these and see that there is a change going on in this data set. So we'll do the same thing for each one of these other items. There's 3 more to do. While I'm doing that, are there any questions that you need answered, or do I need to go back over something real quick? I'm going to repeat this 3 more times, so just keep an eye out. Okay, so the next one that we're going to work on is the channel survey. Our graph says that it's mean low water in feet, just like the other one. So we'll go into the data calculator. I'll double click that. I'll add 2.76. Give it a name, mean sea level in feet. Compute. Then I'll double click the new data set that was created, and then I will multiply that by 0.3048. Give it a new name. Hit compute. We see that it's listed there. We click done and ensure that it is in your data tree. If you just hit the enter button once you have entered that calculation, it will not compute this, and you'll think it's done it, but it hasn't. So make sure that you hit the compute button, hit done, and then ensure that the extra data set has been it shows up in your data tree right here. So for the coastal relief model, We look in the data, the graph here, and it's mean sea level meters already. We're not going to worry about changing this one. Move to the next one. It's field team measurements. And we see that that is an NAVD 88. It's already in meters, so we do not need to change it from feet to meters for this one. So we will click Data, Data Calculator, double click the Z, which we know is already in meters. So we will make the change, subtracting now 0.073 meters from this value. Give it a name. It's now mean sea level in meters. Compute. Done. It shows up. And for our LiDAR, we see it's in NAVD 88, but in feet. And so we'll convert that one, Data Calculator. Double click the Z. We will subtract 0.24 feet. Give it a new name. And then convert to meters. Done, and we're ready to go. Any other questions? Okay. All right, so now we have each one of our data sets is already in the units that we want. So, you know, a lot of people do this different ways. Z is not a very descriptive name. If you want to, you can right-click on this and just change the name if you want. You know it's already in mean sea level meters. That way everything shows up the same way in your tree for the next step. It's up to you what you want to do. This one we didn't change either, so I'll do that one. And so for the next step, what we want to do is to end up with one big bathymetry data set that contains all of the best parts of this information that we've been putting together. So we're going to have to merge these together, and there's a couple of different ways to do that. I'm only going to be covering one of them today. If time permits, I could probably show the other one, but we'll see how that works. So if you read in the book, in the handout, you want to make sure that when you're merging these multiple surveys, you want to delete the overlapping portions of those data. And the best way for me to see that is to go back and only look at the points. Sometimes you can look at the actual triangulation between these data sets, but I'll look at the points so that you see all of the files, all of the points together. So we can zoom into these areas, and you see that I've got red information on top of the grayish information, and we can go through each one of these and see how they relate. So the same thing here. You want to make sure that you keep the information that you want to keep. So one thing that I'll do is I'll only turn on looking at one of these particular data sets. I'll just start out with this 3364 survey, and it's already got some points in there. I can turn on the triangulation and just to see what's going on here. So anything that's triangulated over this, when we merge these points, all of this information could be used, especially if you use the other option when merging, which is called merging with priority. You want to make sure that all of these areas that are covered by these large triangles are gone. And I'll show you how to do that. So in your dynamic toolbar here, between your data tree and your graphics window, there's an option that has an arrow pointing to a triangle. So that means to select the triangle. And you can click them one at a time and delete if you want, but that's, you know, very tedious to do that. So what I do is you can hold down your control key and then drag with your mouse, left click and drag, and anywhere that this arrow touches when you let up will be selected. Another option is to hold down the shift key and just single click each individual triangle if you want. And then when you're ready to delete those, you just hit the delete button, making sure that you're in this window with your cursor, and then hit delete. And then just repeat that over and over again until you get rid of the long triangles for the areas that you don't need. Now, I'm going through this pretty quick, but this is really a couple of steps that you really, it's very tedious and you want to do this over and over until you get the area that you want. And we're not going to go through and do the complete thing right now, but you would want to, if you're bringing in different surveys, you would want to make these changes. So I'll go through and do a couple more. I'll look at the 0.75 meter contour, and what this basically is just showing the outline of a bay inside the domain. Let me see if I have a picture of that real quick. I don't think that I do. Okay, so I'll just move forward. For this one, since we're only needing the points, I'm just going to leave this how it is. And we'll do a couple more here. So hit Control key and use your arrow. You can delete these triangles out. All right, I'm not going to go through all of these. So I'll turn these back on. A lot of times you'll have areas like, let me see a good example here. Like this LiDAR set shown in red now is actually over some other points that are very widely spaced. And those points are in the coastal relief model. So what you can do, or what I sometimes do, is we'll select the points here. Actually, I need to select the points. And just delete the ones that are underneath the data that you're wanting to do when you actually merge these together. And this can be a little bit tedious, but you'll find that, you know, it's worthwhile in the long run. Another way to do the selection of points, also to hit the Control key and then just start clicking out with your mouse. Click out the area that you want to select, and then once you're through, say for this whole area, double click, it selects all of the ones inside that polygon, and then you can do that as well. So you want to go through and make sure, like I said, to delete all the overlapping regions. Otherwise, when you go and merge all these points together, you're going to wind up with a value here that really should be covered by the more dense data set in this LiDAR. So, like I said, I'm not going to go through every one of these, but I will show the next step, which is under scatter points. There's a merge sets option. And now you're given a chance from all of these 6 that we have listed over here. We can turn those on And I found that clicking them individually usually works. Sometimes the select all leaves the data set options locked where you cannot change these. And so what I want to do is make sure that when we merge all of these points, that the data sets that they select are all the mean sea level with meters. That way we make sure that every one of these is in the right frame of reference for what we're doing. And that's why I went through and, even for the ones I did not convert, changed the Z name to something so that I can see that these are all mean sea level in meters. Then once we've finished that, you may have 10 or 12 of these that you want to do, but in our case we have 6. You want to select merge all the scatter points. This other one we may come back to later if there's time. But merge all these points together. We click OK. You can give it a name if you want. It'll default to being just named merged. And I realize that this is not going to look exactly perfect because we didn't go through and delete all of the overlapping points. But we have another data set that we can load in that shows what the merged data set will look like once you're finished working with it. This is one of the more tedious tasks, and it takes a little while to go through and work with each one of these surveys. So it may take a few minutes, hopefully not too terribly long, to do this merging. There's a lot of points in some of these files, especially that LiDAR file, and so it may take a while. And so you see now that we have the original 6 data sets, but we now have a merged data set. I'll turn all these off so that we're only looking at the merged, and then I can frame. And you see, you don't really see a whole lot here. Let me turn on the contours. So I'll make sure I select contours. I'm using a filled range between -5 and 20 like we had discussed. And so the final data set is one big file that contains all the information everywhere in the grid. And once I get closer, I'll go back and I'll turn these points on. I'll change the size of them so I can see what's going on. And so you see that this one data set has not only the points from the coastal relief, but it has the surveys, the points around the bay, all the channel surveys. Everything is in this one data set. It's all red. And that's what we want to end up with at this point. So you can do one of two things at this point. You can either, if you're happy with the way that this is with this merged data set, you can either delete these old data sets out because they're no longer needed since we have that merged data set, or you can leave it in there. I've done it both ways, but when you just remember that if you file, save the project, it's going to save every one of these, so your new project file is going to come back in with these 6 plus the merged. Either way is fine, and so I'll just do that real quick. It'll take a second. I'll look back in this directory, and we see now that we have another file called webinar-merged. But we also have these other files. They were all updated at the same time. So the next time we come in, we're going to come in with these 7 files instead of these 6. And it now saved, in addition to the original data that was there, it has now saved the new several data sets that we created with the data calculator as well. So we have all of those to go back to if we need to. So that's the whole process of converting horizontal datums, coordinates, making sure you're in a common projection, and then also changing your vertical depths to a common datum. Before I move on, are there any major questions that I can go over? Yesterday's presentation, there was a question. I went ahead and posted that on the website this morning. Like I said, if you go back to our SERP webpage to the location that I showed you earlier, yesterday's agenda is still there, but I've added a new option that shows webinar video audio. And so that will download the file. It's about 112 megabytes or so. And that contains yesterday's presentation. I'll do the same thing for every day this week. So after I'm finished processing that video, I'll add it to that day's agenda so you can download them whenever you need to come back and do that. One question that was just asked is, what is the difference between the Z icon next to the merged data set and the 1, 2, 3 icon in the original data sets? And that's a good question. Basically, let me see, when you go to, it doesn't really play as big a point right now as it will later on when we're working with the actual grid, but the Z icon denotes that this particular data set for this scatter set is going to be used for the depths. I can show a little bit more about this later on, but if you wind up with a grid and you have multiple data sets attached to that grid, it could be different types of information. Only one of those is going to be the Z that's going to be written to the actual depths for each cell. You may have other information like hard bottom information. You could have salinity type of information that contains values for every point in the grid. That Z just helps SMS know that that particular data set is going to be written as the depths when it goes to be writing the grid. And I'll show more of that later when we start building the actual grids. I hope that answered your question. Okay, so we're through with this particular section. We can come back later, and if there's time, I'll go back over that other option. Lauren, I'll answer the question about if you can change which one is Z versus 1, 2, 3 later on when we get to working with the grids, because it's a lot easier to talk about that then. So let's just move forward, and hopefully we'll get there by the end of the next hour. So we're making good time. This ended up right about where I wanted it to, using the first hour to go over bathymetry, vertical and horizontal corrections. And so now I want to spend a little bit of time on using this new merged data set to build an actual grid. So let's move on to that. So like I said, I didn't have time to really be as accurate and tedious with this particular surveys that I merged together that I wanted to be. So let's just delete all of the data that's here right now, and you can click the small X under the SMS window, not the big red X, and that will delete everything that's loaded in your data tree. And so let's go to File, Open, and in your bathymetry directory there's a merged folder that has a merged file that's already been processed correctly. And it looks a little bit different, but basically all of the same information is there. All right, and so I'll just go ahead, I'll turn off the points, turn on the contours. I'll explain break lines in a minute. And my contours, I'll just use the same range that I normally did. All right. So to build a grid, you need a few basic things, and the main point of it is using good bathymetry, and that's what we have right now. The next couple of things that you need, and we'll move on, I'm going to use this data just real briefly to show building a grid frame, but the next handout that I gave you actually has some other files that we can work with as well. So I'm just going to use this real quick, and then I'll switch over and I'll use those other files as well, just as an extra way to show things. So for right now, we have the bathymetry, but we haven't told SMS yet exactly where we want our grid to be. So we know that the grid can be anywhere within this big trapezoid. So the way we do this is in the map module. So we click on the map data module. There's also a little compass down at the bottom you can switch to, and it works with different types of coverages that do different things. There's a mapping coverage, there's an observation coverage, there's other general coverage, the shoals type coverage. But more importantly, there are coverages for each individual model so that you have the tools that you need to build that. So what we need to do is I'll right-click on map data and I'll create a new coverage. We can give it a name, and that name I'll put CMS flow. It doesn't matter what the name is. But for the models in the top part, we want to go up to models and look through the list, and one of the options is CMS flow. So we'll choose CMS flow, click OK, and we see a new coverage that has been added down here. When we click that, some of these tools that are in this dynamic toolbar will change from what may have been there for any of the other ones. So just make sure you click the right one. CMS Wave has a different one, but the tools are somewhat the same. And this purple Create 2D Grid Frame is the tool that we want to use. So we click that. You can see it's depressed here. And the next step would be to click out the corners of the grid wherever we want it. And it doesn't, do not have to be that precise at first. You can always resize this later on. But essentially, you want to click your first point, and then that gives it a place to start, and that's the point of origin. And for CMS flow, it does not matter where this point is. Then you click your second point, and that locks it into place on that line. And then there's another line that comes off perpendicular to that, because we're building a rectangular grid. And then you click a third time wherever you want to put that. So it ends up having a purple frame, which we can then select with the grid frame tool. And there's a box that shows up in the middle of this that we can select. And a lot of times these frames get kind of hidden behind all these colors. So one thing that I find is a nice little trick is to go into the display options under the scatter contours, and you can change the transparency of those contours and make them a little bit invisible. So, let's try 40%, and then when I click OK, you can see that it will shade this a little bit, and this frame is now a little bit more visible. So we can grab the center tool here and place this wherever we want. We want to make sure it encompasses the area that we're very much interested in. And so in this case, you can click in the center. If you need to rotate about this point of origin, which is shown by this IJ triad in the corner, there's a tool at the end of the line that's circular. You can grab and then rotate about that. And so let's rotate that, and I'll just kind of make it, what we want to do is make this I or X or Y direction almost shore parallel. And so we'll try to do that as much as possible, and we'll get as much of the grid in as we need. We can extend with these other tools to the left and right, or to the top and bottom, offshore, inshore. And so once you do that, your grid will have its frame, and that's where it's going to be located. You can get some information about this if you double-click on the grid frame. It pulls up the properties for that frame, and so it gives you where the XY origin is located. That was this point here. Then the angle that you ended up with after you rotated, which is here, and then the distance from the origin in the I and the J direction, as well as some other information about the cell sizes that are going to be defined. And we haven't modified those yet, so the default right now is 10-meter spacing. So we just, sometimes you might want to take note of this, put it in your notes, especially if you're going to be coming back to this at some point. Let's go. I'm actually going to stop working with this particular data set right now and go into the data that we have for the other hands-on folder. So I'll go back over some of this in just a second. So I'll cancel this, and I'll close the information out. And now I'll go to my other directory, which is CMS Humboldt. This is Humboldt Bay, California, on the west coast, of course. And so there's several files here, and your notes have a couple of things. What you want to do is in the SMS interface, the first thing we want to do is set the projection. And what we're going to be working in for this particular project is now, instead of New Jersey state plane meters, we're going to be working in state plane California Zone 1, which is extreme northern California. These zones are described in various locations. Usually there's a help button around somewhere. I see it's not on this particular screen, but there are some others that point to the SMS wiki that Aquaveo has, and there are some maps that show the different state zone planes as well as the different UTM planes, so that you know which zone that you need to be in. But for our case, we're going to be working in California Zone 1 state plane in meters, of course. And so we set those. We click OK. If you want to, you can go under File and save your settings. That way the next time you start SMS, it comes up automatically in that same zone. So we can load bathymetry. So in that CMS Humboldt folder, there's some bathymetry that we put together from various surveys and merged together, and that's this one called HB Grid-merged, and I will just load that directly, and it comes in, and hopefully it's not too big. So we see a semicircular area here with a couple of different surveys, some hydrographic surveys that did some lines out here. You can see it's been merged from several different areas. We can turn on the contours and look to see what the bathymetry looks like. I'll go back and turn on the color filled contours. And you can see that by these big values, 3,500 meters, that it goes well offshore. We're only interested for this project in near shore, so I'll put my preferred values here. And we can zoom into the Humboldt area. And this wasn't the best bathymetry as a whole. It's got a lot of information, and some of it is better than others. But for the project that we're going to be working on, which is between North and South Humboldt Bay, the information is good enough for us. So we're going to, at this point, generate the flow grid just like we did before. So we go over to map data, right click, create a new coverage that will name whatever you want to do, CMS flow. You can name it Humboldt flow depending on what you want to do, and make sure you select CMS flow as the model that's going to be used. Select that in the data tree, and then we can start to click out the grid as we did before. Actually, the coverage or the notes that I have here want to go in and define some refine points first, and I'll go into that real quick. Basically, as I mentioned yesterday, there are two different ways for CMS flow grids. We have a telescoping grid, which has refinement based in zones, areas near the jetties and other things. The other type of CMS flow grid is a variably spaced grid, which you specify a point and then increase the resolution around that point. And so you can really go in, and I'll show certain locations that might make a good location increase the resolution. So to do that, we click the CMS flow coverage here. We see there are a couple of options. There's a point option, so we'll click to create a feature point. And basically what you want to do is put points in locations that you know you're going to need a little extra resolution. So I want a certain resolution in my inlet, and so I can put a few points here. Sometimes 1 point is enough, other times 2 points. It just depends. You have to work with it and see what works best for you and for your location. You notice the first couple of points that I did disappeared. So let's go back and we'll turn on some transparency again to the scatter set, and those should show back up again. So we see the points that we created a second. There's an option to give these points information. We're going to do that a little bit later. So just create the points right now. We've got these 4 points. You might want to also increase resolution when we get near a channel bend, something like this. You want a certain resolution to keep certain channels open. So you want to ensure that the resolution through this area is enough to keep flow going through these areas. And so you want to decide on what area is most important to you. You don't have to get all of these depending on what area you're looking at. If you want to keep some channels open, just specify some points. And I'm not going to go and do the whole grid, but I just wanted to give you some instruction on how to do this first. I'm not going to worry about the south side. Okay, now that we've gotten some points defined, what we would want to do is to go back and select those points. So there's a different tool for that. And you can select them one at a time by just clicking on them, or you can drag a box and select several at a time if you know that they're going to use exactly the same resolution. A lot of times you'll have smaller resolution, say for these, than you would here, because this is a much more wide open area. So let's go ahead and do that. We'll select these 4. We can then right click, and there's a choice for node attributes. And you see that you can define either in the I direction or the J direction or both. And so the base cell size is 1, and this is in whatever unit you've specified for your horizontal. So this, of course, is in meters. So let's just choose, I'm not sure what's good for this area. We just kind of have to play with it. For this area, I'm just going to choose 10 meter spacing. That may be too resolved, and may be too little resolved. I don't know yet at this point. One other thing you could do is there's a tool here at the bottom that's called a measure tool, If you want to know about what the distance is from one side to the other, you can click the first point, click the second point, double click to end, and you see the total distance across that particular region was 115 meters. If you know that you want 5 or 6 cells spacing across there to keep the flow open, then you can do the division and figure out that you need about 20 meter spacing in these areas. So that's what I'm going to choose for these. I'm going to select these. I have my select shift key down to do a multi-select. I'll do this one as well. Then I can right click, change the node attributes, and I'll enter 20 for both of these. And they don't have to be the same. They can be a different value. And so in the I direction, it will be one spacing, and in the J direction, it will be a different spacing. But whatever you want to do and whatever looks best to you, that's what you can put in those blanks. I typically make them square in this area, because when you go and try to build the grid, it's going to start from that initial resolution at that point and gradually increase it in both the I and J direction. So you're going to wind up with elongated cells anyway. I see there's a question, is it possible to refine the grid in ST-Wave? I am not a ST-Wave user right now. I know at one time they were locked into having either square cells, or I think in a later version you could have a constant spacing in the X direction and a different constant spacing in the Y direction, but for every cell in those directions it would be a constant. I don't think that they have this truly variable spacing for an ST-Wave grid. But that would be, you should forward that to an ST-Wave contact. I'm not sure about that. All right, so let's move on. So I've set this for 20 and 20. I click OK. I think I've gotten most of these. I'll select this one and make sure that it is, I'll say 30 for this one. Click OK. I've got some other points down here. I don't know what the spacing is, so let's try that again. I'll measure from one side to the other. It's 153 meters. So I can select this point and give it a refinement of, say, 25 meters. And you notice the values that I'm giving here do not necessarily have to be multiples of each other. I had 10 in one spot, 20, 30, 25. It just depends on what you need. Now when you get to the other type of grid, telescoping, which we're going to cover tomorrow, that's not the case, and I'll go over the reasons why tomorrow. So for this particular grid, we're going to right-click and set the refinement for these cells one more time, and for these I'll just make this cell spacing, since it's going through an inlet, I'll make it 30 meter spacing. And then I'm going to just try and build the grid and see what we end up with. This is a very much an iterative process. We have, you can't build a perfect grid the very first time. You just have to build it, look at it, see if it has resolution in all the areas you need to. If it doesn't, then you come right back to this map coverage. You change the resolution from these refined points, and then you rebuild again. So it's an iterative process. You do it over and over again until you're happy with the results. And you may even have a grid you're happy with, but then 2 weeks later, after you've built it and you started running with it, you want to add some resolution in. There's some ways to do that for this type of grid after the fact, and I'll go into that tomorrow as well. So for right now, we've got the bathymetry, we've got our resolution defined. Now we need to define our grid. So we click our Create Grid Frame tool again. and I'll select an area, and it doesn't have to be perfect. Like I said, you can move this after the fact. So in my case, I want to make sure that it's relatively flush with the shoreline here. I'll move to encompass the bays. So this has to come a little bit farther back. I'm not going to worry too much about this north side. You would want to make sure that you fix any kind of problems in this area before you actually build. But for this particular webinar, I'm just going to move forward. Then you would decide how far offshore that you needed to go. And there's different thoughts on this. You want to make sure that you get far enough so that the ebb jet, as you're doing tides, your flow, it's going to have an ebb jet coming between this, and you do not want that ebb jet to touch your offshore boundary. So if you have it really close, then you may find that you need to go back later on and expand that out a little bit. So keep that in mind as you're building your grid. Another thing is you want to include any features that you need to. So you don't want to be chopping this off through the ebb shoal that's shown out here. There's a disposal area right here. If there was something farther off that you needed to take into account, you would make sure that it was far enough that way as well. You can go back and look at the depths. So I'll click this, and we'll see that this offshore edge right now is about 58 meters deep, and that's probably plenty deep for what we need. I think the ebb jet is only going to come out to about here at the worst time of forcing. So let's just move forward. In your notes, it has a grid frame properties. The page numbers aren't on here, but it's figure 4, and there are some values that were entered, and you can actually, if you want to mimic that exactly, we can go back and select this grid frame and change these values to match what is shown in the actual dialog. So let's just do that real quick. So for the origin X, it has 180 to 890, and then the origin Y was 657.050. And I'm just going through each one of these blanks and entering the value, and you can just follow on and do this if you want to work with this later on your own time. And then for the grid frame properties, since we've entered some refined points, we can actually tell this properties dialog to use those refined points. And I'll go into the other information here in a minute. This will not actually create the grid, it's just setting the properties for the grid. So let's click OK at this point. And it's reset my grid a little bit. It looks like it's chopped off the top part of this bay. Evidently we're not too interested in that right now. We're mainly focused on the grid itself, the inlet itself. And so when we're happy with everything, how it's set up, one of the next things that you would do is to, under Feature Objects, you would click Map to 2D Grid. Now, to get that option, you have to make sure that you're in the Map module with the CMS Flow dataset or coverage selected. If you're back up here with the scatter, you're not going to get the same drop-down menu. So if you don't see that, make sure you switch to the right coverage first. And then under Feature Objects, there's a Map to 2D Grid. And it brings up a dialog exactly how we just saw. It just has another little area here at the bottom that we'll deal with. So we want to use refined points, and as a maximum cell size, we will put 180 meters, and that's what it's going to be as far away from these refined points as possible, and that would be in both directions. And then we have a bias, and the bias basically is how fast it increases or decreases the resolution around the refined points as it starts gradually merging those out to where there's no refined points. So these biases govern how fast or how slowly that transition works. So they can be different values. We have 1.08 for the maximum bias on that side and 1.06 for this one. For the inner growth, if those options are checked, what happens is, let me just click cancel real quick and I'll zoom in. So between these points of resolution, what happens is we're only specifying resolution around each individual point. So we'll gradually start increasing the resolution, and then as it gets nearer to the other point, it'll start decreasing again until it gets to that point. Sometimes you may want to keep that resolution constant between the points, and that's what that option that I just described does. And so that would be feature objects mapped to the grid 180. Let me just go through this real quick. If you tell it to uncheck the box for no inner growth, then that will be locked between the refined points. And then for the depth options, you can just use a constant value if you want. What we want to do, though, is to use the scatter set that we so diligently worked on earlier. So we'll use the merged option. So select scatter set. Make sure you choose the right one. There may be a big list of, all different surveys that you had. Remember, we had 7 earlier. So this one we only have 1, and we only have 1 data set for that one, which is a Z value. So we would select that, and then there's an option here for extrapolation. So that means for any point that's going to be created in your grid frame that's not covered with bathymetry from your scatter set, it doesn't know what value to use, so it extrapolates a value. And so you can just give it a value, or you can tell it to use an inverse distance weighted, and it looks at surrounding nodes and sees what they had and try to assume a certain value. Normally, we ensure that the entire domain is covered with bathymetry, and then any value that we specify here may be used for areas, say, of a barrier island or breakwater or something like that, to where we've removed the triangles, and we can say, I know this is never going to be used, and I'll assign a value of -2 or some other value that's out of the range of your tides. And that way it's always going to be outside the domain. So that's what I'm going to do here. I'm going to specify anything for an extrapolated value, use a -2, and that should be immediately evident where that might be, so you can find those points later on. All right, and then there's some other things here not really used a whole lot. You can truncate the values for your bathymetry. If you haven't already done that, you can mess with that. Normally I don't use those options. So let's just click OK here. Linear interpolation is fine. There's other options as well. This is the fastest and usually does a pretty good job. Now there's one last option here for mark cells blank above datum as land. And so basically if you check that, it says that if there's a value, and I always forget what needs to go here, whether it's relative to the depths or relative to elevations. So we'll just try this. So basically it says mark cells that are X meters above the datum as land. So let's try 2 meters above water. So you're looking up above the water. So anything 2 meters above that would be land. And I'll click OK, and it'll start generating our grid. So it may take a while, depending on how much resolution that you've put in, how many resolution points that you've put. Sometimes it could take just a few minutes. Other times it could take seconds. If it takes, too long, you're probably going to have way too many cells for you to reasonably work with, so you might want to kill it and then start over again. So it finished now, and it finally is giving me some warnings. And so it says it found some dead ends and it found some locked cells. And basically, locked cells are areas that have one cell of water surrounded entirely by land. And so that's just probably with problems in your bathymetry. And what's going to happen once you click OK is all of the locked cells will be, I'll just click OK on this isolated water cells. That's exactly what it was talking about. And what will happen is it'll zoom all the way back out. I'll turn off my scatter set and then frame again. And so it shows what the grid looks like. And we see that there's some brownish cells here. And that's just, these are land cells. They will never wet. You see some blue areas between where it's water and land, and those are cell strings, and we'll cover that in a minute. But then otherwise, for areas that had an elevation of, you see down at the bottom, -2 or higher, it's made those as land, and so those will never wet no matter how high the water gets. Other areas are left as ocean cells, which are by default not turned on. And so we see our grid. And you see that there's some issues over here, and this is caused by some errant triangles that we had in the data. And we would want to go through, before we actually move forward in this project, move forward and get rid of any of these problems. These triangles here, you would handle that either by, let's edit by polygon, and you could click out an area that you know is going to be land. I'll just do a little bit area here so you can see what's going on. Select those, and then you can right click and change the attributes for those cells to be inactive land. Now that doesn't get rid of the cell strings that were created, but it does get rid of, or it does make all the cells inside that land where they will not be affected. So the cell strings that were created automatically are not all needed by SMS or CMS. So what I normally do is I'll keep the one that is generated on the outside. That's this one for the ocean. And all the other ones, for the most part, are not needed. And you see that there are tons and tons and tons. That's indicative of bathymetry issues or other things that you want to see what's going on. So it creates a cell string whenever it sees discrete areas that are surrounded by land or separations of land and water. And so anything like this that you see a cell string out by itself just means that there was a water cell inside that needs to be taken care of. And so you could change that in a couple of different ways. If it's an area that you look at and you know that you need to have resolution to resolve that area, you could go back in to your coverage for CMS flow and create another resolution or resolve point. Right click and give it some resolution refinement. And then regenerate your grid, and then that particular area would probably be handled. I don't have time to go through all of these different places, but that's kind of what you would want to see. You would want to look at the grid, how it is, make sure that everything that you need to have resolution has the appropriate resolution. If you need flow through an area, you need at least, normally at least 3 cells, but we recommend at least 5 cells across an area that needs good flow to come through here. So if you can't see how many that is, you can come to your display options, and now we have a Cartesian grid, and turn those on. Click OK, and you'll see the ocean cells show up, and you want to make sure that you have at least 3 or 4 or 5 cells across, so that when the land side of these dry, there's enough cells to represent the flow through the middle. I hope that describes appropriately. The next thing that I would do is, once I get all those issues resolved as far as adding enough resolution, and you have everything resolved that you need to, if you still wind up with a lot of these cell strings that you don't need, let me just turn these ocean cells back off again quickly. What I would do is to click on the grid and then choose to select the cell strings, and that's what this tool here does. Edit with the polygon and just click. I don't know what happened there. Let me try that again. Edit, select with polygon. All right, and just click a box that contains all of those. Then you can click delete, and then they're all gone. Of course, you would want to clean up all the areas that you need to. Once you're finished with this and you're ready to move forward with a grid, it doesn't have to be the most perfect grid at first, but with a grid that you want to move forward with, make sure that you go back and you click File, Save a New Project. We haven't saved a project here before, so let's just name this Humboldt. I'll just name it again like I did before, Webinar. You'd want to give a name that you can identify what's going on, what grid you're working with. Of course, you're going to have these in certain areas. You're going to have your different projects in different areas. And so we see that, you know, all the files that I just had loaded are now listed in the grid, and we have certain files that are listed here. So we have a cards file, which basically holds the parameters for CMS flow. We have a grid, which is basically every cell that's in the grid, whether it's wet, whether it's dry, what kind of forcing it has, any kind of cell-specific information would be stored in that particular file. You don't need to know this. You can't look at it really. And then also the MP file contains any kind of other model parameters that doesn't necessarily have to do with cell specifics. So it might be wind, it could be river flow, it could be water surface elevation, forcing, things like that would go into the MP file. So that we can all start with a good grid. Say we've gone through, we've cleaned up everything. We want to see what a good grid will look like. I'm going to go ahead and close this and load my other project. So there wasn't a project saved with this. There's just the individual files. So if you click load, to load a CMS flow project, you can just click the CM cards, the parameter file, and drag and drop that into the interface. All right, and then we have a couple things that are listed over here. One is Manning's Inn. I haven't gone into that yet. But I'll show you in just a minute. But we also have the depth. And so we see our grid, we see the various bays that we've got here. And then that gives us a good basis to move forward. Are there any questions real quick for this? I know I kind of went over this a little bit quickly, but you have the notes and you have the files. and you can play around with this. I would suggest that you do this, and just to get comfortable with the interface, with creating the grids, creating the refine points, resolving the issues that might come up as far as not enough resolution in some places. It's a good exercise to do for you guys. If there's no other questions, let me see if I had scheduled to cover anything else today. So we can go into the model, the various parts of CMS flow, and how to specify any kind of forcing and parameters. And so we've got the grid, we've got our ocean defined, our land defined. We need to tell CMS how to actually force the information onto our boundary conditions. And that's done through cell strings for forcing conditions, and then other ways to bring in winds and waves and setting other parameters. So let's just go ahead and start working with boundary conditions. And so one of the options, like I said, to bring in boundary conditions, you work with cell strings. And this grid originally, since this is grayed out, you can tell that it does not have any cell strings defined right now. So SMS has added some capability to automatically generate some cell strings for you. And so what I would like to do is generate cell strings along the open boundaries. So I'll click that, and you see now that that's finished. We have a blue border around our grid, and that's basically our cell string. And so we can select it now. You left click there, and then under CMS flow you can assign BC, that stands for boundary condition, or you can right click and assign the boundary condition. And there are various types. There's I'll go into some of these later on, or I'll let Alex cover them next week in the advanced. But for the most part, the ones we normally use are water surface elevation forcing. There's a flow rate forcing that is grayed out right now. That would be for specifying a river flow. And the reason it's grayed out is that you cannot supply forcing information for a river that makes a corner on the boundary. Otherwise you'd have flow coming in this way, flow coming in directly normal to that, and you wouldn't want it to do that. So you can only have the flow rate forcing boundary condition if you have a cell string that is only on one edge of your grid. So if you had a river, I'll zoom into this area and kind of define an area for you guys to see. What we could do is to specify a cell string, and I'll click that out and generate one right here. If this was a river that had adequate flow, that you would want to include that into your domain or into your grid, you could then create this cell string, assign a boundary condition, and the flow rate forcing option is available now. And you would just supply a curve that was basically time in hours and a flow rate, meters cubed per second, and you notice it says per cell. So you want to make sure that if you have a flow rate of a certain amount coming down this river that's been measured by a gauge, and you have 4 cells to represent that, that the value that goes in here is the total value divided by the number of cells. Then you would click OK and make sure you give the entire series here. Click OK, and then that information would be associated with that particular cell string. I'm going to go ahead and delete that one because I don't need it right now. And I'll show how to specify the other types of forcing, which is water surface elevation forcing. And so basically it would be to define a curve just like we just showed for the flow rate, but in this case it's water surface elevation in meters. If you get your data from a gauge that you're wanting to force with and it's not in meters, you need to make sure that it is in meters before you put that value in here. Everything with CMS has to be metric. Also, the time in hours, it doesn't specify here, but you want to keep everything time related for CMS in relative to GMT, not to a local time, but to the Greenwich Mean Time. It doesn't necessarily play a big factor when you're using local water surface elevations, but it does play a factor if you want to compare with measurements, and those are in GMT, or if you want to force with tidal constituents, those are always relative to GMT. So make sure that you always specify your times relative to Greenwich Mean Time, or UTC. So you bring in a value. If you had already provided these, you can export that so it's easier to pull in. You can cut and paste from, say, an Excel spreadsheet or from some other location. What I've done is I went ahead and brought in from Excel spreadsheet and created a curve and then exported that out with this export button. So now I have an actual value here to use for water surface elevation forcing so that I can import. And so we see this is time in hours from the start of the simulation, so it's relative to 0. And you specify that initial time somewhere else. I'll show you in a minute. So you bring in your curve and you're able to see what that tidal curve looks like. And this is a long run. It's for 744 hours. You would click OK, and then that is stored. So the next time you come in and select that same boundary condition, it's still there. Like I said, if we had a flow boundary here, I'll just go ahead and create another one real quick. I actually had some flow information that I can load in as well. And so we see it's this first one is negative 0.34 meters cubed per second per cell throughout time. And it does not have to be at the same interval as your water surface elevation. It can be any time through here as long as you have a curve specified. So just click OK and then come back out, and now you have your two different forms of forcing. There's a couple of others, but I'm running out of time for today. I'll cover the rest of those types of forcing tomorrow, and the other model parameters, and also how to force with winds. And then later in the week, when we go over how to create our wave grid, I'll show how to put the two together, the flows and the waves, and run in a steering mode. Now, to answer the question earlier about how to designate a data set 1, 2, 3, or Z, there's an option, and this isn't a good choice because Manning's is not necessarily a depth, but if you had, let me just create another value here. If this was your depth, I'll just add some information here. Say if you did some kind of interpolation and you wanted a new value to be used instead of the old values. If I were to save the grid at this point, what would be saved for the Z is not my new depth that I created. It would be the old depth. So I need to find a way to make this new depth the new Z. And to do that is under Data. There is Map Elevation, which I wish for our grids it would be called Map Depth. But it's Map Elevation, and then you would choose which one that you wanted to be the new Z value for the grid. You would select that, and when it's through, now the new data set has the Z value when you go file and save, it would then save the new depths as opposed to the old depths. And hopefully that has answered your question. Another question that came up is negative flow in or out of the model. And right now it depends. And we're trying to resolve the issues. And basically, our implicit model handles these flows in one way, and our explicit model handles them in a different way. And we're trying to make sure that both of the model types use the same convention for everything. And so the explicit model, if we run that, basically the direction is dependent on where the point of origin is. And so let me show the IJ triad on our flow grid. And so we have the IJ triad here. This is our point of origin. For this particular cell string, let me just turn that on real quick. It's hard to see. Let me turn my contours off. Let me try that one more time. Cartesian grid. Let me turn my contours off. Okay. Okay, so I've got my two different cell strings here. And this I direction, so positive is in this direction, moving away from the point of origin. And since the angle of this, positive, if you want flow into the domain, the value here would need to be negative for positive into the domain. If it's on a different corner of the grid, like I said, you need to reference this IJ triad to make sure your directions were coming in or going out in the right direction. For the implicit model, a positive value is always into the domain and a negative value is always out of the domain. And that's what we're going to carry forth in the next version of the explicit model that's going to be available in SMS 11.1. That version, both the implicit and explicit will use the same convention where positive is into the domain and negative is out of the domain. And I'm sorry for the confusion between the two models. We're trying to resolve and make sure that both of our models and everything we do, what's available in one is available in the other, and how they're handled in one is the same way it's handled in the other. And that was one thing that kind of slipped through the cracks, and we didn't find that out until it was a little bit too late. And so hopefully that answers your question, Attila and Lauren, about the flow in or out. Are there any other questions before we wrap up for the day? Okay, there's another question. Can the offshore cell string for specifying the boundary condition just include the offshore boundary cells and not connect to the land cells? And the answer is yes, absolutely. What happens though is let me just delete this out. And I'll recreate this by hand. If you automatically create your cell strings, it always wants to connect it up to land, out to the corners, and then back around. But if you want to create it yourself, you can define a new cell string and just choose the corner and the other corner and click enter. All right. And so what happens is if you select that as your forcing and you specify water surface elevation, you will get the flow in and out in that direction, no problem. If nothing is specified on these side boundaries, CMS treats the non-existence of a cell string or any type of forcing as a land boundary. So if you have the flow coming in here and you were to have flow directed towards this edge and you didn't have a cell string that allowed for it, it would hit the edge and start wrapping around coming up the outside. So you want to make sure that you have some type of boundary condition on this side if you want the flow to go out. And so I hope that kind of answers your question. What you could do is specify another water surface elevation boundary condition on the side and provide zero forcing, but that's probably not something you would want to do. We don't have any problem whatsoever when you force near the land. We take care of all of that without a problem. You don't have to worry about the cells going dry or wet. All of that is handled okay. There is another option for this if you're in steering with waves, but I'll have to cover that on probably Wednesday or Thursday, probably Thursday. And that's called the cross-shore boundary condition. Does that answer your question, Matt? All right. Any other questions before we wrap up? We've got about 4 more minutes. Another question is, can you assign boundary conditions in each string cell? And I'll have to cover that tomorrow because it's a little involved, Patrick. But basically the answer is yes. And where you would get that information is you would extract that information from a larger solution that you've already run or from a title database. You could load an ANSERT grid or some other larger domain grid that has a solution and extract that information. And then each cell along the boundary would contain its own value and not use the same value for the entire length of the cell string. Vincent, for the wave information, the questions about that, let's hold off until I start talking about the wave. And that way we'll deal with all that at one time. Can you bring that back up again on Thursday? Any other questions? Next question is, does the water surface elevation boundary condition, is it assumed at your preset datum? And the answer is yes. So you have the top of the water column is considered zero mean sea level. And so any forcing that you have that you're providing on your water surface elevation is from that zero datum. And that datum could be mean sea level, but it also could be NAVD 88, which is not exactly zero, but your water surface elevation forcing would be coming in at the same datum as your depths are located. You wouldn't want to use a water surface, a mean sea level datum for your depths and then use a water surface elevation datum from mean low water or from NAVD 88. You have to make sure that everything matches up. I hope that answers your question, Rod. Any other questions? Well, if not, we're going to wrap up for today. We'll be back tomorrow at 1 o'clock Central Daylight Time. We had some people yesterday thinking it was Eastern and they missed it, but hopefully everybody was here today that needed to be, and we'll see you tomorrow at 1. I'm going to post the audio video from this recording later this afternoon onto the website, and so if you need to go back over that, you'll find a link there by the end of the afternoon, and also all the files should be there as well. So if that's all, you guys have a good night, and we'll see you tomorrow. There's a question about PDH hours, and yes, I've already talked to our leaders here, and there's no problem in giving PDH hours. Basically what we'll do is we have to show that you guys were here and how many hours, and then we'll get all that done. I'm not exactly sure how to get it out to you guys that need the PDH credit, but we'll figure that out before the end of the week. Okay. Well, I'm gone for the day, and I will see you guys tomorrow.